Hello, welcome to the video lesson, or video notes for lesson 3.7. This is more about the domain and range of a function. So we've already explored a little bit about domain and range in the previous two lessons. Now we're going to do a little bit more. Our target for this lesson is I can, given the domain of a function, determine the range of the function. Again, something we've already seen and done before, but we're going to take it much further. We're going to get a lot more involved. So, like the last video, in the last lesson, this might be a little confusing, so make sure you pay attention, and certainly ask questions if you have any trouble after watching the video. Alright, so we're going to take a look at parent functions. And a parent function is the simplest function for a family or group of functions. And you'll see all the names across the top of the different examples. We have linear, absolute value, quadratic, exponential, and cubic. Some of these we've seen before. I think this is the first time you've ever seen cubic, but for the most part, a lot of these will make sense and be pretty understandable for you. Alright, so let's take a look at the linear parent function. And the equation is just simply y equals x, or f of x equals x. So what's the domain of that? Remember, the domain is all the input values, or all the x values. Now, this graph is a little inaccurate because there should be arrows on either end of this line, because it continues on forever in this direction and in this direction. So if you think about all the x values that keep going and going and going this way or this way, where would they end? Well, they wouldn't. So that's going to be negative infinity up to positive infinity. And since technically they never could land on infinity, we're going to use the parentheses. Now, this is interval notation. This is not the point, negative infinity, positive infinity. This is interval notation saying that x is greater than or equal to negative infinity, or less than or equal to, or not equal to, less than positive infinity, greater than negative infinity. So we could say the same thing about the range. It will continue to go on forever, upwards or downwards. So the y values, remember, go vertically up and down. So again, just like the domain, using interval notation, we have negative infinity up to positive infinity. Okay? Alright, so now we have absolute value. And you should recognize this graph. It's V-shaped. And the parent function is y is equal to the absolute value of x, or f of x is equal to the absolute value of x. So what's the domain? Again, domain is the x value, so going horizontally, left to right, right to left. And no matter which way you go, it's going to continue on forever. So negative infinity to positive infinity. Cannot equal them, so we use the not equal to or parentheses. Alright, now this time, for the range, remember that's our vertical values up and down. The range is y. So it can continue upwards forever, so that's infinity. But when we go down, we stop right here. And when we stop right here, if you look at the y value there, that is 0. And it is equal to that. So we're going to use the bracket. It's equal to 0 or greater than, all the way up to infinity. Alright, quadratic, very similar to the absolute value, although the shape is curved and not V-shaped. Oh, you know what the heck? Bonus point, or make it a two-pointer, for anybody that can remember the name of this graph, or the shape, if you will. and bring it up without me even mentioning anything. If you just say, Mr. Decker, the name of a quadratic graph is, you tell me what it is, I'll give you a bonus point on your scoreboard. Alright, back to the domain. Same as the absolute value, negative infinity up to positive infinity. And the range is also going to be equal to 0, because it's right here at the origin, but continue upwards forever, so that's infinity. Okay? Alright. Exponential. Okay, so this can go, now I know it's getting very steep, and it looks like it might be going straight up eventually, but it will still always have some sort of slant to it. So it's always going to be positive infinity and negative infinity. A exponential graph will get very, very steep and look almost straight up and down on one end. And on the other end, it's going to get very, very flat and look almost horizontally flat, but it's not. But it'll continue on forever and ever in both directions. So, now, here's what we're going to say for the range, however. It is not going to ever cross this line here. It can never reach 0. Now, since it can never actually reach 0, it is not equal to. So unlike absolute value in quadratic, we're going to use a parenthesis because it's not equal to, all the way up to positive infinity. And then our cubic. This is the first time we've seen this. This is actually a lot like the exponential, although it does flip over the x-axis. And because it does, the domain is, just like all the rest, negative infinity to positive infinity. The range, however, is not like exponential, quadratic, or absolute value. It will go up or down forever. So negative infinity to positive infinity. Essentially, cubic and linear have the same domain and range. Alright, so let's answer these questions down at the bottom quickly. Which parent functions have the same domain? Well, if you pay close attention, they all have the same domain. Which parent functions will never have an answer equal to 0? And there is only one that will never be equal to 0. Linear and cubic do cross over. So when we say answer, we're talking about the range or a y equal to 0, an output, if you will. So that is, will it cross over the, or touch the x-axis. And the only one that does not is the exponential. Remember, the range up here was the interval notation using the parentheses, not the bracket. All the rest were either crosses over it or will touch it. Exponential. And then which parent functions will never have a negative answer? So, again, which of them will never cross over the x-axis? Now, quadratic and absolute value touch it, but they won't cross over it. And we already know exponential will never touch the x-axis. So those three are the ones that will never have a negative answer. So, absolute value, quadratic, and the last one, exponential. Alright, let's take a look over at the next page, which is page 39. We have some more examples we're going to talk about. I know the video is starting to get long, so I'm going to quicken this up a little bit. 1a, determine the range for the function f of x equals 10 minus 5x for the domain, and then we have this. Alright, so I wish I had a little more space here, because what I like to do is set up a table for something like this. And my table's getting sloppy. Let's Let's try that again. There we go. Where I put 10 minus 5x, and then our f of x, or our range. Okay, so my domain is -3, -2, -1, 0, 1, 2, and 3. And then I substitute the value in. So 10 minus 5 times -3, that's going to be -5. Then I've got 10 minus 5 times -2, that's going to be 0. And then the next one is going to be 5. And then the next one is going to be 10. So you can actually see the pattern, and what's happening here is it's going up by increments of 5. So the range is f of x equals, because we have a definite set of points here, so this is going to be a roster. We go from -5, counting by 5s, all the way up to, and then the last one would be 25. Now if you plug this into your calculator, your graphing calculator, in the y equals 10 minus 5x, you will get, if you look in the table, you'll get all the values for y, or f of x. 5, 10, 15, 20, and 25. Okay, now part B says determine the range for the function f of x equals 10 minus 5x for the domain. Now this is talking about all the values that are greater than or equal to -3 but less than or equal to 3. So what that means is, now we're talking about this kind of an answer. So we're going to basically write this same thing. We're going to have, but instead of x in the middle of this, we're going to have f of x. And then, so it's going to be is greater than or equal to, or is going to be less than or equal to. Now use these values. What is my smallest value? It's -5. And my greatest value is 25. And there you go. And that's the answer for that. Alright. So I want you to try the next one on your own. Set up the table for x, and then x squared minus 5x, and then find your g of x this time. You're going to be using the values all the way up from 0 up to 5. And you're going to find, so you're going to plug in 0 and get an answer. And then what you're going to do is you're going to give the roster form. And then down here you're going to give a form that's going to look like this, where you're going to have g of x in the middle, and you'll use your answers up here to find the smallest and your greatest value. Alright? Okay. And then down below we have a graph. On the graph below, sketch the linear function that is decreasing over the domain. Now notice this is interval notation. We got -3 to 6, where it can be equal to 6. So here's our lowest x value, and here's our greatest x value, and has a range of from 7 to -4. Again, our lowest y value, our highest y value. So our lowest x value is -3, 1, 2, 3. And our lowest y value, or the y value that goes with that, is 7. So I go up to 7. Because it's on the left side, okay? Now, I actually need to make this an open circle, because this is telling me that it is not going to be equal to. Now, find the other point using the 6 and the -4, plot it. Actually, let's go ahead and do that together. So we go over 6 and then down 4, and put a shaded circle, and then you connect them, and you're done. Yes, I know, we're going to need to practice this. But I think it'll make sense for a lot of you. If you had any trouble, go back and rewatch the video. Remember to answer the A and B up above this problem here. I want the range for both of them. If you can share those correctly in math, maybe I'll give you another point or two on your scoreboard. If you need any help, make sure you come and see me, talk to a friend, or get help from a parent, older brother or sister. Good luck, and we'll see you in math.